This is Dr. P Srilatha, Associate Professor, Department of Mathematics, Institute of Aeronautical Engineering, Hyderabad. So in this session, I am going to discuss about test of hypothesis for difference of means. So what is test of hypothesis for difference of means? Already we have discussed test of hypothesis. So test of hypothesis for single mean and test of hypothesis for single proportion and the test of hypothesis for difference of proportions. Sorry, difference of means. We have discussed these three topics. So this means x bar minus mu by sigma by root n. So the formula of test of hypothesis for single mean is z equal to x bar minus mu by sigma by root n, and test of hypothesis for single proportion is z equal to small p minus capital P divided by under root of pq by n, and test of hypothesis for difference of means is z equal to x1 bar minus x2 bar divided by under root of sigma 1 square by n1 plus sigma 2 square by n2. So this is the formula for test of hypothesis for difference of means. So now test of hypothesis for difference of proportions. Here also we are having two samples. Okay, so test of hypothesis for difference of proportions means double proportions, two proportions. Okay, so here also we are having two samples. Okay, so consider two large samples. What is large sample? We know that if n is greater than or equal to 30, then we can say that is large sample. Okay, so if n is greater than or equal to 30, then we can say that is large sample. Okay, so consider two large samples of size n1 and n2. So taken from the population, the sample proportions are small p1, small p2, and the population proportion is capital P. And then the test statistic is given by, so test statistics means the formula. So the formula for this test of hypothesis for double proportion or a difference of proportion is z equal to p1 minus p2 divided by under root of pq into 1 by n1 plus 1 by n2. So z equal to p1 minus p2 divided by under root of pq into 1 by n1 plus 1 by n2, where p equal to small p equal to n1 p1 plus n2 p2 divided by n1 plus n2. So this is the formula. So small p equal to n1 p1 plus n2 p2 divided by n1 plus n2, and q equal to small q equal to 1 minus small p. Small q equal to 1 minus small p, or you can write this is x1 plus x2 divided by n1 plus n2 also. Okay, so where p1 equal to x1 by n1. So we know that the population, so the sample proportion. Okay, so already we have discussed in the single proportion in previous session. So the sample proportion is small p equal to x by n. Okay, so here like that p1 equal to x1 by n1 and p2 equal to x2 by n2. Okay, so p1 equal to x1 by n1 and p2 equal to x2 by n2, and small p equal to n1 p1 plus n2 p2 by n1 plus n2, or that is equal to x1 plus x2 by n1 plus n2. So q equal to 1 minus p, and the main formula is here test statistic z equal to p1 minus p2 divided by under root of pq into 1 by n1 plus 1 by n2. So problems. So our first problem is random sample of 400 men and 600 women. So a random sample of 400 men and 600 women were asked whether they would like to have flyover near their residence. 200 men and 325 women were in favor of proposal. Test the hypothesis that the proportion of men and women in favor of proposal are same at 5% level. Okay, so the random sample of, so coming to the question, the random sample of, that means sample of means that is nothing but sample size. Here the sample size is 400, and also we have one more, so that is one more sample is there. Okay, so random sample of 400 men and 600 women. Okay, so here we have random sample for women also. Okay, so for random sample for men is n, let us consider that is n1, and this is random sample for women is n2. So let us consider random sample for n1 is random sample for men is n1. So that is n equal to 200, n1 equal to 200, and also let us consider the random sample for women. Women is 600. That means that is, let us consider that is equal to n2. So were asked whether there is they would like to have flyover near their residence. Okay, so 200 men and 325 women are in favor. So they liked. Okay, so favor for proposal. So what is that proposal? They asked whether there is any, they would like to have flyover near their residence. They are asking this one. So that is our proposal, right? So this is favorable. So these are favorable. So in that 200 men and 325 women were favor. Okay, so in favor of those proposal, that proposal. So here the favor, in favor of the proposal means, let us consider this is x value, but here we are having to know, so for men and women also there. Okay, so for men that is x1, so that means x1 value is 200 here, and for women let us consider that is x2. So that means here x2 value is 325. So n1 is 400 and n2 is 600. So like that x1 is 200 and x2 is 325. Okay, so test the hypothesis that the proportion of men and women in favor of proposal are same. Okay, in proposal are same at 5% level of significance. At 5% level of significance. So let us consider alpha equal to 5%. That means alpha is 0.05. Okay, so here we have n1, n2, x1, x2. But here we need to calculate p1. So what is p1? P1 is nothing but x1 by n1. So what is P1? P1 is nothing but x1 by n1. So here x1 equal to, what is x1 here? x1 is 200 divided by n1 is 400. Okay, so that means that is 0.5. So like that P2 equal to, so we know that P2 is formula is x2 by n2. So we know that already we have discussed. So P1 is x1 by n1 and P2 is x2 by n2. So P2 is nothing but x2 by n2. That is, what is x2 value? x2 is 325. So 325 divided by n2. n2 is 600. Okay, so that is equal to, so 325 divided by 600. So that means that is, if you calculate this one, we will get 0.541. Okay, small p1 is 0.5 and small p2 is 0.541. But we need to calculate small p and small q. So what is the formula for small p1? n1 p1 plus n2 p2 divided by n1 plus n2. So what is small p value? n1 p1 plus n2 p2 divided by n1 plus n2. So this is a small p value, or you can take x1 plus x2 divided by n1 plus n2. So this is small p value. What is q? Q is nothing but 1 minus p, 1 minus small p. Okay, so here we are finding for p. Okay, so p equal to, so p equal to n1 p1 plus n2 p2 divided by n1 plus n2. So n1 is, I will calculate here. So what is p value? So here p equal to n1 p1. So what is n1? So n1 p1 plus n2 p2 by n1 plus n2. So n1 is, so here n1 is 400. n1 is 400 into p1 is, here p1 is, p1 value is 0.5 plus n2 value is 600 600 and P2 value. So P2 value is 0.541. So 0.541 divided by N1 plus N2. So 400 plus 600. So if you calculate this one, so this is small p value. If you calculate this value, we will get 0.525. So that value is this value is 0.525, small p value. So what about small q? Small q is nothing but 1 minus p. So 1 minus 0.525. So 1 minus 0.525 is 0.475. So this value is 0.475. Okay. So here we have calculated all those values. Okay. So we have P1, P2 and small p, small q. So small p is there, small q is there, and P1 is there, P2 is there. So and also we have N1 and N2. So what is the formula? For which formula is suitable for this question? So that is P1 minus P2 divided by under root of PQ into 1 by N1 plus 1 by N2. So this formula is suitable for this question. Okay. So according to our formula, we can find the solution. But before that, how to solve this one? So we have, so these are all large samples. Check whether these problem is these values are large sample, or this question is large sample question. Okay. So what is large sample? We know that large sample is nothing but n greater than or equal to 30. So if n is greater than or equal to 30, then we can say that that is large sample. So here n value is 400 and here also n value is 600. That means here also n is greater than or equal to 30, n is greater than or equal to 30. So n is greater than or equal to 30 means this is a large sample question. So now we have to follow the procedure for large sample tests. Okay. So what is the procedure? First we need to write the null hypothesis. And after that, we need to write the alternative hypothesis. Next, we need to write the level of significance. Next, we need to write the formula, that is Z test statistics. Next one is conclusion. So what is the conclusion here? If mod Z greater than Z alpha, we reject H naught. Okay, so if mod Z is less than Z alpha, we accept H naught. H naught means our given statement. Okay, so our given statement. So what is our given statement? Test the hypothesis. The proportion of men and women in favor of proposal is same. Okay, so that is our given statements. Here, the statement I am taking is as it is. Okay, so null hypothesis. So null hypothesis means that is denoted with H naught. So null hypothesis is denoted with H naught. So that is nothing but P1 equal to P2. Okay, so alternative hypothesis, that is H1. Okay, so here alternative hypothesis is nothing but P1 not equal to P2. Okay, so what is alternative hypothesis? So we know that alternative hypothesis differs to the null hypothesis. That means simply we can say that alternative hypothesis means it is quite opposite to the null hypothesis. Here P1 and P2 are equal. That means the given statement, what is that statement? So the proportion of men and women in favor of proposal are same. So here we are taking the proposal of the men and women in favor of proposal are same. So that is our null hypothesis. That means here we are taking in null hypothesis given statement as it is. Okay, so that is our given statement. That is nothing but null hypothesis. So alternative hypothesis is nothing but opposite to the null hypothesis. Okay, so opposite to the null hypothesis. That means P1 not equal to P2. So that means opposite to the null hypothesis means the statement is the proportion of men and women are not favored for the proposal. That is not same. Okay. So alternative hypothesis is P1 not equal to P2. That means that is two-tailed test. Okay, so already I have discussed in the previous session in test of hypothesis for difference of means. If we have double means or double proportions, we need to take two-tailed test. Okay, so double means the difference of means, that is double proportions means the difference of proportions. In difference of test of hypothesis for difference of means, in test of hypothesis for difference of proportions, we need to take two-tail test. Okay, so that is quietly opposite to the null hypothesis. P1 not equal to P2, so that is a two-tail test. Okay, so next, coming to the next point, that is third step. What is that third step? Level of significance. So already they have mentioned alpha value. Alpha value is 0.05. So that means, so alpha value is 0.05 means that is 5%. That means here alpha value is 0.05 at, so are in the case of two-tail test, alpha value 0.05 or 5% in two-tail test. In two-tail test is Z alpha equal to 1.96. So Z alpha value will be 1.96. So this we can take from the table. Okay, so I have discussed this one table value in the previous session. If you have any doubt, you can see that previous session video, so you will get the clear idea about this. Okay, so Z alpha equal to 1.96. That means that is stable value. Okay, so that means that is stable value. We have taken this value 1.96 from the table. So how to take this Z alpha value from the table? So in table we have two-tail test and alpha value. So alpha value, at alpha value 0.05 in a two-tail test, then Z alpha value will be Z alpha equal to 1.96. Okay, so like that we can take from the table. So next step, our fourth step is test statistics. Our fourth step is test statistics, that is equal to P1 minus P2 divided by under root of PQ into 1 by N1 plus 1 by N2. So this is our formula. Okay, so in the test statistics we need to write the formula. So what is that formula? So these all values are suitable for this formula, right? So because this is two sample here, we have two samples. So two samples means either we will get test of hypothesis for difference of means, or we will get test of hypothesis for difference of proportions. Here in the question they have mentioned that is proportion, right? So and here we have x values and n values, not means. So that's why we have to take that is test of hypothesis for difference of proportions. That means that is equal to the test statistics Z equal to P1 minus P2 divided by under root of PQ into 1 by N1 plus 1 by N2. So we have to use this formula. So in this formula, what is P1? So P1 is 0.5 and P2 is 0.541. So P1 is 0.5 minus P2 is 0.541 divided by, so divided by under root of PQ into, so what is P value? P value is 0.525. So P value is 0.525 into, what about Q value? Q value is 0.475. So 475. Okay, so into 1 by N1. N1 value is, so here N1 is 400. N1 is 400 and N2 is 600. So from that we can take N1 is 400 plus N2 is 600. Okay. So after simplification we will get 0 point. So this value is, after simplification we will get, that is minus 1 point. So simplify this one. So if you simplify this one, 0.5 minus 0.541 divided by under root of PQ into P value is 0.525, Q value is 0.7475 into 1 by N1. N1 value is 400. That is into 1 by 400 plus 1 by N2 value is 600. That's why 1 by N2, that means 1 by 600. If you simplify this one, we will get Z equal to minus 1.28. Okay, but we need mod Z. Okay, so but we need mod Z. That means we have to convert the solution into positive. So mod Z equal to 1.28. So mod Z equal to, so here mod Z equal to 1.28. So last step, so that is conclusion. So what is the conclusion here? So mod Z, that is 1.28, and Z alpha, so already we have solved here, right? We have taken from the table, okay, so that is 1.96. So this is 1.96, okay. So mod Z is less than Z alpha or greater than Z alpha. So here we have mod Z value, that is 1.28, and here we have Z alpha value, that is 1.96. So whether 1.28 is less than 1.96 or 1.28 is greater than 1.96. Yes, it is 1.28 is always less than 1.96. So that's why modulus of Z less than Z alpha. So we know that this value we have calculated, okay. So we have calculated from the formula, okay. So mod Z value we have calculated from the formula. That means that is nothing but calculated value, and we have taken this value Z alpha value from the table. So that's why that is tabulated value or table value. Okay, so tabulated value, so and this is calculated value. So here we got calculated value is less than tabulated value. So we have got calculated value less than tabulated value. That means we accept null hypothesis. So we accept null hypothesis. So null hypothesis is nothing but H naught. So that means we accept. So we accept our statement, our given statement, okay. So we have taken the given statement, so we accept our given statement. So what is our given statement? So the given statement is the proportion of men and women in favor of proposal are same. So that is our given statement, okay. So that's why the given statement is correct statement, okay. So the given statement is correct or the given statement is true. So next, go for the second problem. A manufacturer of electronic equipment. So next problem, problem 2. A manufacturer of electronic equipment samples of two completely brands of transistors to an accelerator performance test. If 45 of 180 transistors, 45 of 180 transistors are of first kind, and 34 of 120 transistors are second kind. To pass this test, that we can conclude that can we conclude at level of significance 0.05 about the difference between corresponding sample proportions. Okay, so what is the question here? A manufacturer of electronic equipment samples of two completely brands of transistors to an accelerator performance test. If 45 out of 180, so out of 180, how many samples are there here? So here we have 180 samples. That means here the sample size is 180. Here the sample size is 180. So that's why n equal to 180. So that means here we have 2, no? So that's why I am writing, so n1. Okay, so sample size is that means the total number of transistors are here in one sample, that is 180. That's why I am taking n1 equal to 180. So and out of 180, 25 transistors are first kind. Okay, so that's why, so we can take this is x1. Okay, so this is x1. So x1 equal to, so here n1 equal to 180 and x1 equal to 45. x1 equal to 45, and 34 of 120 transistors in the second sample. So in the second sample, how many in the second sample, how many transistors are there? 120 transistors are there. So that's why in the second sample, the size of this sample is 120. So that's why n2, size of this sample is denoted with n, but here we have two samples. Okay, so that's why we are writing n2 equal to 120. Okay, and how many are second kind? So that's why this is so these are pass the test. Okay, second kind of to pass the test. That means here we have to take, that is x2 value. So x2 value is 34. x2 is 34 and n2 is 120. Okay, so now we need to find P1. So we know that P1 equal to x1 by n1. So we know those formulas, right? So P1, so we know that the sample proportion formula we know. Okay, so what is sample proportion? P equal to x by n. So number of exhaustive events divided by total number of events. So x is number of exhaustive events and n is total number of events. P equal to x by n. So from that we can write P1 equal to x1 by n1 and x1 by n1. So what is x1? x1 is 45 divided by n1 is 180. So that's why P1 equal to 0.25. So here P1 equal to 0.25. So like that P2. So what is P2 value? P2 is nothing but x2 by n2. So x2 is 34 divided by n2 is 120. So that's why that will be 0.25. So P2 equal to 0.28. Okay. So what is small p value? So we need to find small p value. So that is small p equal to n1 p1 plus n2 p2 divided by n1 plus n2. So this is the formula for small p. So what is n1? N1 is 180. So 180 into p1. So p1 is here 0.25. 0.25 plus n2. N2 value is 120. So 120 into P2 value is 0.28. So divided by N1 plus N2. So what is N1? 180 plus N2 is 120. So 180 plus 120. So small p value. So small p value is 0.263. So this value is 0.263. Okay. So what about Q? So Q equal to 1 minus P. So 1 minus 0.263. So that is equal to 0.737. So this value is 0.737. So Q equal to 0.737. So which formula is suitable? So which formula is suitable for this problem? So here we have N1, N2, P1 and P2 and a small p and a small q. Okay, so the formula is suitable to, so P1 minus P2 divided by under root of PQ into 1 by N1 plus 1 by N2. So this is the formula we have to use. Okay, but we have to follow the procedure for large samples. So what is the procedure for large samples? So here we have the procedure. Step 1, null hypothesis. So null hypothesis is denoted with H0. So that is equal to P1 equal to P2. Okay, so here we are taking this statement as it is. So what is that statement? Can we conclude that level of significance about the difference between the corresponding sample proportions? Is there any difference between the sample proportions? Here I am taking, there is no difference between the sample proportions. So there is no difference between the sample proportion is our statement, right? So here I am taking the null hypothesis is our given statement. There is no difference between the sample proportions. That means that is P1 equal to P2. Okay. So what is alternative hypothesis? Alternative hypothesis denoted with H1. So what is alternative hypothesis? Opposite to the null hypothesis. So here I am taking the two sample proportions are, there is no difference between the sample proportions. Here I am taking, there is no difference between the, no difference between sample proportions. Sample proportions is our given statement. So that's why P1 equal to P2. No difference. But here I am taking, there is a difference between. So there is a difference between sample proportions. So this is alternative hypothesis. That means opposite to the null hypothesis is alternative hypothesis. That's why that is P1 not equal to P2. So already we have discussed about P1 not equal to, if P1 is not equal to P2, then we can say that that is two-tailed test. So P1 is not equal to P2 means that is two-tailed test. Okay. So next step is step 3, level of significance. So what is the level of significance here? So already they have given that level of significance is 0.05. So 0.05 alpha value they have given that 0.05 and alpha value 0.05 in two-tailed test. Alpha value 0.05 in two-tailed test. Then Z alpha is 1.96. We have to take this value from the table. So already I have discussed in the previous sessions. Okay, so go through those videos, then you will get the clear idea about how to take Z alpha value from the table. Okay, so I will give the link in the description. Okay, so go through those videos, then you will get the clear idea about how to take Z alpha value from the table. Okay, so here you have to take Z alpha equal to 0.05 in two-tailed test. That will be Z alpha equal to 1.96. Okay, so that is we have taken from the table. So this is from table. So this value we have to take from the table. So next one is step 4. So what is our step 4? Step 4, Z equal to P1 minus P2 divided by under root of PQ into 1 by N1 plus 1 by N2. So this is the formula. Okay. So already we have discussed, right? So what is the formula? Which formula is fit to this problem? So this formula is fit to this problem. Z equal to P1 minus P2 divided by under root of PQ into 1 by N1 plus 1 by N2. So this formula is fit to this problem. So that's why Z equal to P1 minus P2 divided by under root of PQ into 1 by N1 plus 1 by N2. So what is P value? So P1 value is 0.25. So this is 0.25 minus P2 value is, where is P2 value? 0.28. So that is 0.28 divided by under root of PQ into, so what is PQ? So P value is here 0. So this is P value. So P value is 0.263. 0.263 into what is Q value? So Q is 0.737. 0.737 into 1 by N1. So what is N1 value? N1 value is 180. So 180 plus 1 by N2 value. So what is N2 value? So N2 is 120. So here N2 value is 120. Clear? So solve this one. You will get minus 0.57. So this will be minus 0.57. So but we need mod Z, right? So mod Z equal to 0. We have to convert into positive. So that's why this will be that is 0.57. Okay, so we have to convert into positive. Okay, because we need mod Z value. Mod Z is nothing but 0.57. Okay, so mod Z is 0.57. So here we know that mod Z is 0.57. And what about Z alpha? We have taken from the table. So Z alpha is 1.96. So 1.96. So here 0.57 is less than 1.96 or greater than 1.96. So that is 0.57 is always less than 1.96. That means mod Z less than Z alpha. So we know that we have calculated this value, right? So that's why this is calculated value, and we have taken this Z alpha value from the table. So that's why this is a tabulated value. Okay, so always if calculated value is less than tabulated value, that means mod Z less than Z alpha. So we accept the null hypothesis. So that means what we have taken in the null hypothesis. We have taken in the null hypothesis, that means the given statement. What we have taken in the null hypothesis is that means the given statement is correct. Okay, so we accept. Okay, that means that is correct statement. So what is our given statement? There is no difference between the sample proportions. Okay, so here we conclude that there is no difference between the sample proportions. Okay, so that is test of hypothesis for difference of means. Okay, test of hypothesis for difference of means. But how to find whether it is a single mean or single proportion? Single mean or difference of means, single proportion and difference of proportions. Okay, so single mean means here we have one sample. Okay, so here also we have one sample. One sample will be there. Okay, so here we have two samples. So here also we have 2 samples. Okay. So but here it is one sample with mean.
Like, share and subscribe. Hit the bell icon for more updates.